Welcome to Talking Tuesday. I am your host, Fancy Quant, and today we're going to talk about something that's work related with the Careers in Motion here, season 5. And it's going to be kind of more of like a technical video that should be on the YouTube channel, but I think it plays well into the careers and looking at issues. And also the big concern and worry, which I see a lot, people saying, Dimitri, my job is going to get automated completely away because obviously model development and validation and all this quant finance thing is easily automated by machine learning and data science and AI, and so we're just going to go by the wayside. No, this is very, very far from the truth and complete nonsensical. So I figured I'd talk a little bit about a project that was at a firm that was a multi-year project. I think it was like 5 years when I was involved in some of these issues. But it was, how do we automate model validation? We had some individuals that was almost like their full-time job, was just figuring out how to automate this and then create a really nice, easy software application where you could go in, you could basically just feed in, like, this is the model, this is the basic information. So the goal of this was that, one, you would specify the model. Two, it names the model for replication here, and it runs it all and does the replication and outputs all your coefficients in the same model structure, and you can use that to check it. And then third, it would generate all the possible analysis that we would ever want under the sun automatically, hands-free. It would just go in and do it because it would know you did this type of model. This is all the stuff we need to look at, and it would be done. And this sounds doable if you haven't worked in model validation or model development, or you've done it from a very simplistic standpoint, and you just feel like it's the same steps over and over again. And I struggle with this because I sit at a higher level of seeing how these things work. There are governance teams that work on these things, and they set guidelines and processes and procedures, and we want repetitive understanding of how things are done. So the steps that every validator should do should be the exact same. And yet when you do these things in practice and you go into the weeds, while we're all doing the 4 big main areas here, which are going to be, data, input and data, conceptual soundness, the model specification, or the final kind of results of it. And then finally the output and the analysis. They're going to have these areas where it's like, okay, you have the data. This is the final model. These are the tests that you did to make sure it ran. And then finally, there's typically like a documentation section or whatnot, or like conclusion area or additional testing. And so when you have these, right, I jump on my soapbox here. I'm getting all excited. These are the same steps you do for everything. So it doesn't matter if it's a statistical model, if it's a machine learning model, if it's an AI model. It's the same steps for everything. And this is my other grinding complaint is people now think there's new steps for data science and machine learning. It's the same process. There's no reason to change your governance here, which is the process and procedures we follow to do model validation or model development. It's all the same things. And so it seems really easy, but then when you start diving into the data, the problem with finance is the data itself changes very drastically. And there's just some areas of finance, the majority of it, there's very sparse data. So when you add a handful of data points, like 5 to 10 data points, like the model acts crazy and like the data that you started with looks nothing like this new data. And you're trying to build models for this, and the analysis changes, and there's always, I guess you can put ad hoc, there's always specialized analysis you need to do based on the specific data you're doing. And at a bank, like my team, I think was responsible for over 80 models. So you can imagine 80 models are for 80 different problems, and there's different analysis for this. So while we could break down our credit risk in itself, the majority of credit risk is done through different sorts of models like logistic regression, which is extremely common because it can do things like probability of default. In anyways, something simple like logistic regression here, you would assume that, okay, we can automate this process. This is what you do. These are the things you look at. And if it passes these 5 checks, then you're done and the model's perfect. Now, the issue, though, is not necessarily the modeling a lot of times. It's going to be the actual application of the model. Now, different businesses, so the people actually use these models or have some sort of need here, have different ways they want to use it. And depending how you use it, the model needs to be structured differently. So variables that are required or can't be put into the model. So there's our regulations that restrict different variables in some models, but you can use them in other models. And, accuracy across the entire board versus accuracy within specific pockets or populations or segments here are extremely important. It can be the difference between you losing, $1 million for the month or losing $15 million for the month. So these are things that need to be considered, and there's a lot of analysis and kind of things that you need to know to go into this. And one of these processes and procedures is called weight of evidence, which is the way that we bin out variables. There's another name for it. I think it's like discretization, and they call it in machine learning, but we call it WE, which is weight of evidence. And it's how we take variables that are like continuous in time and we chalk them up into categories, and each category is statistically significant, meaning each category within that range is about the same. So there's an example here quickly. Imagine age, right? People that are going to be less than 18 would be like one value. So we're not going to have like your age is like, 12, 13, 14, 15, 16, 17, 18, or 16, 17, because the next bin would then be like 18, 19, 20, all the way to, let's say, I don't know, like 21 maybe. Maybe that's like a real, maybe for some reason there's a cutoff there. And then maybe from like 21 to like, 32 or something is statistically significant as another pocket. And then you'd have another grouping above that. So you assign all these individuals in these segments or groups one value. And that value is an assignment based off of the dependent variable, which is what you're trying to model here. So if you're trying to model probability of default, you use that and you figure out the relationship with that and the variable here, let's say age, for each specific value, and then those values are assigned. So they start to lose meaning here in a way because one, you have groupings, but two, those values are assigned based off of weight of evidence, which I'm not going to get into. That's too technical for the podcast. I would need a whole screen and a whiteboard and to write all these notes. But anyway, so you go through these processes, and often the way that it statistically is the most optimal way to do it, we look at it from a business perspective, and we know for a fact, like, oh, these customers, for example, if you're less than 18, you can't get a loan. And so if we had any of those in there, those are issues and errors. So those need to be flagged. Or perhaps we just need to remove that record as a whole because maybe it was supposed to be, I don't know, like 26 or 36 years of age. And for some reason, somebody mistyped it and it was just 6. Like they missed the first letter. Maybe they missed the last letter. Maybe they're like 60 something. So there's quality control checks and things that need to go into this. The way that weight of evidence works too, there's like rank ordering. So we have a variable and we want a linear relationship and we're modeling PD, which is probability of default. We expect there to be a monotonic relationship, meaning as you go up, so an age here for an example, as you get older and older and older, you'd expect the risk of them actually defaulting would probably be lower and lower and lower because they've worked longer, they're more stable. Again, age isn't used in models, but if it were, this is the relationship you'd expect. Sometimes though, your data doesn't come in like that and that's not how it works. And so you have like a data point that's no longer monotonic. So as maybe it's increasing, one data point drops and then it goes back to that same pattern, or maybe 2 data points drop. Sometimes it's because you just don't have enough data in that bin. There's a sparse data issue. So you can program and set rules like, okay, if there's a, minimum of 30 per bin, and you can go through this. The problem is when you start going through building these models, there's lots of these nuanced details or issues. And a lot of times it takes expertise in building these models where I'm using statistics to give me some sort of output. The human needs to look at it, then they need to make a decision and they need to do it. So this is the whole automation thing. The reasons it failed, though, there's really 5 main reasons on why this project as a whole failed. 1, the data processing, cleaning, and preparation varied a lot for each project that would come in. So you would assume that we're all one big corporation and it would go to the specific data warehouse or the data lake and you'd pull all this data from there and it would of course be processed and cleaned and have quality checks, and it does. But sometimes businesses require data to come in from different sources or different tables. And sometimes it's not in the same formats. And sometimes there's lots of issues with it. So they might not check the quality at the same scrutiny that we're checking the quality. Or maybe the tables are just structured a bit differently because one's coming from like the finance department and one's coming from the operations department and one's coming from like an accounting department. And so when you're starting to put data together, it doesn't match. And there's nothing wrong with it. We have easy ways to logically go through and match them by, customer ID or key or whatnot. And so we can go through and fix that. But now the problem was the automation didn't fully do all of this. And so now, people that love automation, and one of them in general, think, oh, okay, we'll solve this problem and we'll do X, Y, and Z. The problem is a lot of times the structuring from each of these departments would change. And so there's really no way to nail down and get a really nice, clean process here. So one solution that was brought up is, okay, we'll manually do all the data processing at the beginning. And then once we have a nice, clean data set in the format that validation likes it, then we'll run it through the model. But it's a Band-Aid and there's a lot of work here. The second issue and reason why this failed is there's too much output that had to be sorted through. So I remember running this tool. I was strongly against the automation because I knew struggles and like the reality of automating these things is extremely challenging when you're doing this at a high level, and models matter more than just like, generating how accurate you are. But when businesses need these for actual decisioning, there are other things that matter. And we'd run it, it would just print like 1,000 pages of charts and tables and information that I just didn't need. And so now I would have to go through it manually, and sometimes I'd get lazy and I'd print the whole stupid thing, because then I could take it with me while I'm like, traveling or commuting, or I'm at home, or I'm somewhere else, and like I can just sort through these sheets, and I'm going through it's taking me hours. Because hours and hours and hours of going through these dumb charts just to figure out which chart I need. And finally, when I get to the chart I need, I mark it. And then I keep going because I don't have time to look at anything now because I'm just sorting through so much garbage here. So the second issue here is there's too much garbage to sort through, which was not effective, which was too time consuming. Again, the whole point of automation is to speed things up. This was slowing things down. The third one is when an issue was found, manual analysis was still required here. So if a chart came in or something, I found the chart and I have the data, and okay, this number is too high or too low, or it's in violation of X, Y, and Z. The model was built by somebody else. So even though it's flagged, I still see, it's a problem. A good validation team doesn't just say, here's a red flag, it's a problem, and throw it back to development. It's our responsibility to dig through and see why that problem exists. And maybe it's an issue on our end. Maybe we didn't set the coding up, or maybe our data wasn't set up correctly, or maybe development screwed up. But we need to come up with a potential solution for them so we can go through and look at that and say, okay, I understand now why it's a problem. Maybe it's a limitation. Maybe we can't fix it, or maybe there's a really easy solution and they miss something, right? You still have to do that manual process. You still have to go back through and do the analysis. So even though it's automated, even when I find that chart, which I spent months digging through, these thousands of pages of documents, when I get to that, I still have to do the analysis manually. There's no way to automate that piece because it's going to be varied based on every project here. The fourth main issue with this is anyone proficient in SAS, which is the language of the tool we were using at the time, could actually code out and do the replications faster than the automated program could. And what I mean by this is kind of touching on the first 2 points. You would go in and set it all up, and I could teach like anyone to set it up, and then you could run it. So the interface was great, they developed. The issue though was that like going through and sorting through the data, the pages, and then having to go and figure out how to manipulate your output that this automation did to get the analysis that you needed, it took more time. And the issue is I could actually run the replications I had, and it could even debug developers' code. Sometimes it doesn't run as expected. Well, it's just like 95% of the time. You have to go in and change the library names, of course, and all that, but there's usually like an issue or a bug or something's not done right. You have to go in and fix it, and then I rerun it, and I get it to work. Now, if that code the development provided has an issue, or the data itself has an issue, the automation's going to somewhere catch it in the middle, and you still got to fix it. But anyone proficient in SAS that could code all this stuff out in like a week and be in and out on a lot of this issue, and then we could focus on the additional analysis and on the writing the reports and everything else. And then it would take, a few months total. But, if you're proficient in the language of the tool you're using, which was SAS for us, but if you're using Python and you're automating, if someone, excellent in Python or R or whatever language you're using can write just as much code and do the analysis quicker, right? It's a fail right there off the bat. So that was the fourth big issue. The fifth issue, though, is manually built models by an actual expert were beating automated models. So part of this whole process was going through the validation, running their models, matching the replication of the model. Is also to find, challenger models or to see if there's other better approaches that could have been done. So it would have been this great and amazing tool where you would run through like their logistic regression. It would output their results. Then it would output like 5 other possible models that are logistic regression that are better. It would do some decision trees. It would do, maybe a neural network or something else. And it would generate all this stuff and say, oh, here's 10 other better methods and, X, Y, and Z. My colleague too, even the guy that was building this, one of the guys was going on and on and on about he was an expert and whatever. And I mentioned to him, I said, you got to realize I've worked with people in other industries, not even finance. I've worked with people in finance and done this, day in and day out. I can build, so my specialty is in time series. I can build time series models that beat the automated ones, like the AutoArima model packages and all that. And what you're doing in this code, I can beat it every single time, or at least 9 out of 10, maybe 99 out of 100. Like, I can beat it, and I've seen other people, that have built models, and I've seen your automated tool. It's not beating what's being built. So the people building these models are experts, and your stuff's hardly ever beating it. And when it does beat it, there's machine learning methods that were beating it. We'd go back and look at it, and you couldn't use it because some of the stuff that was put in there was nonsensical, or there were issues with variables that shouldn't have been in there that were in there because of regulation. You can't have them. And then again, now it takes us time to tear these other models apart because even though it's a valid, fancy schmancy model that came out of this, I still got to make sure that it's a functioning model for what the business actually used and needed it for. So this automation here, the reason it failed, the reason the majority of teams that I see trying to automate validation teams, or like model development or any of this sort of thing, is they think it's a machine learning like tech exercise where it's like, okay, we're going to run a bunch of models through this and then we're going to pick out the one that fits the best. And in practice, there are a lot of constraints and issues with this. There's also, when you start considering these issues and constraints, it actually takes more time. And then you have people like me that are experts for building models. And when we go in and we show you like, oh, the model it generated fits amazingly well and, whatever, in like machine learning models, I can go in and say, oh, look, this is why it overfitted and here's exactly how it overfitted. And, if you just want to throw mud at the wall and hope it sticks, here's 10 other models outperform that are far simpler, that are not overfitting. And then they go, oh, well, right. They don't know what to say with it. And so the reason this automation, I don't think it's like something bad, but I think the whole reason SAS exists, the whole reason other tools, like I know some companies are using like DataRobot, which I have never used. The reason these tools are being created is it's supposed to be a way to do things faster. Now, SAS, I'm a big proponent of SAS. People complain, oh, it's not as fancy as Python and it can't do all this other stuff. It doesn't need to do all this other stuff. It's literally designed and optimized to build statistical models, right? So they're working on data science things. I don't believe it's very good for any of that, but for stats stuff, it makes it simple. So I can type in a short snippet of code, I get exactly what I want, and I can tinker with the code a little bit and get the exact things I need. So SAS, in a way, is an automated shortcut of doing this. Now, it's not an automated way in the sense that you like hit run and it generates a bunch of models. I know they have software that does this, which I think is complete garbage. But like the base enterprise guide SAS just makes it more efficient to code. And I think that's where we need to realize a lot of this theory, a lot of this processes, a lot of the expertise in this that go into this aren't going to be as simple as like, here's data, chug into this model here and hit run and like it'll output a bunch of stuff and select the top 5 and a human will look at the top 5. I know people are doing this. There are times when you can do this, but you really are going to have to still go into deeply looking at the model structures, the model designs, the ethical ramifications of some of these models, which is what banks are required to do, the regulatory requirements behind this. There's just a lot to it. And when I try to explain this often to those doing the automation, they start to think like a model is steps 1 to 10. And I start to say, no. It's like a massive decision tree. It depends where you are in the tree. And they go, okay, well, let's build the tree out. And so I hand them my textbooks here. And I go, here's a 1,200 page textbook. And they go, no. Just tell me the 10 steps. I go, no. That 1,200 pages is just the tip of the iceberg. If you can't automate 1,200 pages into a program, you're not even going to be in the the playing field here, the ballpark here for even what we're trying to do. Because finance is complicated. It's complex. Building these sorts of models is challenging in itself. There's even humans that go to build models. And I've seen humans spend months and months and months and months on models, even a year, and they don't come into a solution. There's not a tool that can model some things because they're not modelable. And so this is kind of where this automation piece comes in, is addressing this from a career perspective of, what we can really automate well is setting up data structures and pipelines. We can help automate some of the validation processes and procedures to help make it smoother. But you can't automate the full thing because there's so much analysis, there's so much nuanced detail into it that goes into these, that it's very, very hard to even automate these things because the data that we have in finance coming in isn't the same sort of data. It's not the same type of data. It doesn't even look like it's coming from the same source often because finance data is just non-stationary and it's modeling human decisioning and behavior, which is often very irrational. So these are some of the struggles we face. I think firms could do a better job at some of this automation, and we could automate pieces and parts of things to kind of get these things dialed in a little bit better. But in general, it's not going to be something as easy as automation. I've seen the world's largest global banks spend tons of money on this, and they've came up with almost nothing here because it's such a big problem and it's so complex, the amount of models and things out there available as well, that it's hard to really figure these things out. You really do need someone who knows what they're doing theoretically. So on the business theory side and the stats and math theory side, as well as like the actual implementation of like coding and programming and getting results, and then finally interpreting all those and then figuring out what you should and shouldn't do based on the results. So anyways, that is my take on why automation within model validation and model development, which is more or less quantitative finance, is such a big problem, and it's not nearly as easy as people think it is. And I don't think it's ever going to truly be automated. We will automate parts of things. You're always going to need an expert, someone to come in and build things and do things a little bit better, especially in finance where money matters. Every nuanced detail, every little bit of edge that you can get, whether it's, increased fit and accuracy or robustness, which is what we're really seeking for money and profits here. Getting that is the real challenge here, and is, there's still dollars involved. We're going to try to optimize those and do the best we can. Again, automation hopefully saves us time, but having true experts is going to be here, I think, for a long, long time. So anyways, thanks for listening. Thanks for watching. And as always, until next time.